Hello everyone. Welcome to another webinar promoted by SoftExpert. Today's event introduces how Six Sigma reduces costs and increases customer satisfaction. The webinar will be conducted by Martin Greenaway, an engineer with over 20 years of industry experience in quality. He is responsible for implementing and maintaining quality systems as well as business process improvement by applying TQM, Six Sigma, and lean manufacturing methodologies. I wish you all a great webinar.
Good morning, or possibly afternoon or evening to everyone who's joined us today from around the globe. First, just a little bit about myself. I've been working in quality all my life, from inspector through to a quality manager at various organizations. My background is in engineering. I have a first-class honours degree in mechanical design and manufacture, and I also gained an MBA from Leicester University. Now, for the last 8 years, I've been working for the United Kingdom Accreditation Service, assessing the competence of management systems certification bodies who undertake quality management certification in a number of industry sectors. And I now run my own consultancy. I continue to provide technical assessor resource to UCAS, as well as providing consultancy and training in quality management and process improvement. I'm a chartered quality professional with the Chartered Quality Institute in the UK, and also a PECB certified trainer as well. So that's just a little bit about myself. I first came across Six Sigma when it emerged within manufacturing industry in the mid to late 90s. My first experience of quality management was through BS 5750 and ISO 9001, as well as QS 9000, as well as studying formal IQA courses at the time, and my own further reading on quality management as my interest grew in the subject area, including, of course, the requisite readings of Deming, Duran, and Crosby. And what first struck me about Six Sigma was the structure of the program, as well as the detailed analysis techniques that it used. And basically, it's amalgamation of a lot of learning I'd done up until this point into one coherent approach to improvement. So hopefully I can pass on some of that learning today, and perhaps kindle some interest in you all in researching or studying this area of knowledge a little further. In terms of the objectives and the format of today, okay, well, the main objective is to provide an overview of Six Sigma for those that maybe have heard the term and are interested to know a little more of what it's all about. It is a large body of knowledge, which I couldn't possibly cover in any real depth in the time available. However, we do have some time for questions and answers at the end of the webinar, which I will attempt to answer. And also feel free to contact me afterwards. I'm quite happy to discuss or respond to queries or questions, or even just general talk over email about quality management, Six Sigma, process improvements. Okay, so let's move on. So we start with the question, what is Six Sigma? Okay, so I'd just like to outline what Six Sigma is, and hopefully this will explain the title of the webinar also a little further. Now, there are many definitions, explanations, and also claims to the ownership of Six Sigma, but reading the title of this webinar, you might be forgiven in thinking, well, this looks a little like the mantra of quality management, which we've heard for decades. Well, in my learning, both in terms of what might be considered pure quality management and what might be formally titled Six Sigma, I believe these really are the same thing. But as mentioned in my introductory slide, what Six Sigma brings to the broader body of knowledge of quality management or process improvement is a defined methodology, key structural requirements to enable improvement, as well as an analytical approach to improvement, all tied within a project structure to deliver quantifiable business improvements. Now, I deliberately use the term business improvement, and this relates us back to the reduction of cost as contained in the webinar title. A criticism of traditional TQM or quality management has been the pursuit of a perception of quality for quality's sake. That is, the improvement generally never has to be justified in the business sense within traditional quality management. Now, Crosby tried to address this in his seminal works, saying that quality functions had to talk the talk of business, i.e. hard cash. However, he failed to provide a coherent methodology of achieving this, and he also set the bar very high with his zero defects mantra. So what is Six Sigma? Well, the definition I like to apply is that it's a structured methodology for achieving process improvement related to business results, which harnesses many traditional and well-exercised quality tools and techniques, as well as leveraging the power of statistics and analytics as necessary to drive real improvement results. And as the slide attempts to show there, Six Sigma can really be seen to have its roots in the teachings of the prominent thinkers in quality management. And for those that don't know, that is Deming, Crosby and Duran, as well as others. Okay, so a little more on the structure of Six Sigma. As mentioned, it's a structured approach to improvement, but what is that structure? Okay, well, the structure can be considered as organizational, as well as a methodology and a training and competence structure. An organizational structure is really where it starts. Many quality improvement initiatives fail because there's a lack of top management commitment, which results in a lack of time and other resource for improvement activity. What Six Sigma does, it requires organizational structure before you even start implementing any further activities along the road to improvement. And that means appointment of people from the very top level of the organization with Six Sigma responsibilities, and capacity and resource planning that allows people the time to engage in improvement activity. So as the slide shows, the organizational structure is further cascaded down the organization via trained and competent individuals for which the Six Sigma methodology has attributed its famous colored belt system, which it adopted from the martial arts world. Now, in my opinion, that's a little unfortunate and a little corny, which can be off-putting, really, the colored belt system. However, if the mention of colored belts arouses the cynic in you, I would say please suspend your cynicism and proceed with the rigorous training program on the tools and techniques of Six Sigma, as well as recognizing levels of learning and associated responsibilities within your organization. By all means, drop the colored belts references. Okay, a little more on the structure. So within the structure of Six Sigma is the defined methodology, which is captured by the acronym DMAIC, which stands for Define, Measure, Analyze, Improve, and Control. Now, many of you may notice the resemblance to the Plan, Do, Study, Act cycle, which was first defined by Schuhart and later plagiarized, adapted, and promoted by Deming as Plan, Do, Check, Act. As mentioned earlier, Six Sigma very much draws and relies on tools and techniques which have been around for approximately 100 years. Now, improvement projects, they follow the path of the DMAIC cycle. They often have stage gates between each phase that you see, similar to a design project where progress is only approved following evaluation of each phase by senior managers or project sponsors, technical personnel. And it can be an iterative process rather than a simple linear passage to the intended improvement. So you can go around these loops of define, measure, analyze, improve as you refine your approach to achieve the improved result. Each phase, as shown on the slide there, has numerous tools. Again, I think many of these will appear familiar for those that work in quality management or even general management or other disciplines. There's also, of course, a scattering of statistical tools across the DMAIC phases from which Six Sigma draws its name. So the slide there shows the structure, and it's just one example. That there are many derivatives in terms of the named tools for each phase, and an internet search can probably give you 100 different examples. However, they all contain or retain certain essential core elements, all within the DMAIC structure. So why Six Sigma? Why the name? It's a good question, and perhaps many of the statisticians amongst you out there, or even anyone who's studied maths to a reasonable level, would recognize the reference from traditional statistical mathematics. Those with traditional quality management background may also recognize the reference from statistical process control techniques, including capability analysis and run charts, these kinds of things. For the uninitiated, the Six Sigma reference relates to the measure of variation of a population that is normally distributed about a mean value. What does that mean? Well, to use a simple example, the heights of people all vary, and I'm sure we all recognize that. And whilst we see most people of a certain average height or thereabouts, we also probably know some very short people and some very tall people. If we were to measure a reasonable sample size of the population chosen at random, and we plotted the frequency of counts of people of certain heights, we would have a graph resembling the shape shown. Now, this is known as a normal distribution. It has other names, but I'm not going to go too far on statistics today. And for anyone that's interested, I am the over 175 centimeters, so I'm in the top end of the curve. Okay, now the shape of this curve, it's characterized by equations, and one of which is the measure of variance or spread about the mean value. Now, this value is denoted by the Greek letter sigma in mathematics. The equation is shown, but I won't go any further at this point, other than just to mention the lowercase s is used to denote standard deviation of a sample rather than Greek sigma, which relates to the population. I don't want to go too far on statistics today. It's a whole maths lesson that would fill up this time and plenty more. But I just thought I'd explain that point for the statisticians looking at it. Okay, so this distribution, it's common in many areas where you have random variables that have a general central tendency, but also potential for extremes of values, and subject to what is termed common cause variation, i.e. variation that's inherent in a process design. Now, this has been useful within precision machining, where tight dimensional tolerances have to be held by the machining process, and analytical processes such as capability studies and the use of run charts have been deployed to understand and track the variance, generally with a view to adjusting the process before any defective parts are produced, i.e. out of tolerance dimensions. Now, process improvement can be achieved by reducing the variance or spread of the process output, by shifting the mean value to a target value, or stabilizing a process over time such that the mean value and variance doesn't change over time. In an ideal world, if the process variance spread of plus or minus 6 sigma is achieved within the process specification limits, then only 3.4 parts per million will fall outside of the specification limits and be rejected. Now, this also accommodates a 1.5 sigma drift of the mean value. Like I said, I don't want to go too far into statistics at this point, but I just need to state those things. Hopefully the slide shows that graphically a bit more clearly. So if your population is drifting, as you can see by the blue and the pink bell curves there, and you can retain that within plus or minus 6 standard deviations, you will get 3.4 parts per million rejects or defects per million opportunities. Now, this is obviously 3.4 parts per million is near perfection, obviously, but it's not quite the 0 defects that Crosby had hoped for. So within Six Sigma, although the process might not be very normally as shown, the metric of 3.4 parts per million or defects per million opportunity is also used as a metric and considered the attainment of Six Sigma and world-class performance. And many processes will fall far short of this ideal value. Again, just to mention, the theoretical lineage of the above approach goes back via Deming to Schuhart, who also taught the importance of understanding and controlling normal process variation. But I would say this is not what Six Sigma is all about. It is a tool set and a methodology, not just a calculation of standard deviation. That is where it draws its name. It has a focus on process variance, but it is not just statistics. Okay, so how Six Sigma reduces cost. As I've already outlined above, Six Sigma has a heritage built on TQM and quality management philosophy, which stretches back decades, and it utilizes many of the same tools and techniques, and it's ultimately about quantifiable process improvement. As such, how it affects reductions in costs can be considered largely to be the same as any quality management approach. So this slide shows the traditional concept of the cost of quality, promoted mainly by Crosby back in the day, where you have basically three categories of costs. You have prevention costs, you have appraisal costs, and you have failure costs. And you can see some examples of those underneath the headings of each section there. Now, this approach is often modified within organizations to focus on the failure costs, so the failure side, i.e. the cost of poor quality. And that's highlighted in the red box there, the potential failure costs of an organization. This slide, it shows those costs plotted as a chart. Now, this is known as the PAF model. That's what it's commonly referred to in quality management. Now, although its exact shape has been challenged over the years, it does outline a need to achieve an optimum quality level within the financial constraints of an organization, market, or even an industry. So there is a financial consideration to quality, as there is to any activities of a commercial organization. Sometimes, of course, the cost of failure can be immeasurable, for example, where it leads to loss of life. Poor quality can also result in customer defection, as well as lead to reputational damage, such that gaining a new customer becomes even more difficult, time-consuming, and therefore more costly. So the cost of gaining a new customer is often considered to be far outweighed by the cost of keeping a customer by meeting their requirements. Okay, just one more slide regarding costs, which I've put in there. It's kind of a lesser known theory. This is showing what is known as the Taguchi loss function, where it's argued that any deviation from an ideal value leads to losses experienced by a customer or by an end user or even by broader society. Now, this slightly counters the more widely accepted theory of maintaining process output within specification limits in a kind of pass or fail situation, where it passes if it's in the limits, it fails if it's outside of the limits. The Taguchi loss function argues that what the organization should be doing is constantly seeking to target the process output on an ideal target value by reducing variance and targeting the mean, as we mentioned earlier. So quality cost considerations have been around for decades, with various models and theories put forward, most of which appear intuitively correct, i.e. if you make bad products, you will suffer financially. Within the Six Sigma approach, however, is the hard linking of process improvement to quantifiable cost metrics. The DMAIC approach also requires detailed cost justification for an initial project selection, It gathers baseline cost data for current process and translates this into cost data for improved processes. Okay, how Six Sigma increases customer satisfaction. As you've seen from the previous slide, any improvement in process output in terms of products or services should naturally increase customer satisfaction, as the customer is looking for products and services which meet his requirements and expectations. Now, key to achieving this, however, is knowing and understanding what your customer actually wants, and the DMAIC process has at its very front end various tools for identifying and harnessing customer requirements, needs, and expectations, and then translating these down the organizational processes into process outputs which meet these needs. The main tool or approach used within DMAIC is the voice of the customer approach. Okay, so when we engage with our customers through the normal course of business, there will be many avenues of customer feedback and customer satisfaction related data within an organization. But these are reactive, however, and although they're useful, there is of course a risk of reliance on the feedback in the first place. And as we know, some customers will just walk away. There will be no feedback. They just won't return. But voice of the customer also requires a proactive approach to obtaining information on customer requirements, needs and expectations, and it utilizes approaches shown, and if you look down those as well, you might consider those as part of a traditional marketing function of an organization. You've got various things like surveys, focus groups, benchmarking, and of course market research. Okay, just to mention one more tool at this point, which is often included in the DMAIC cycle, and that is quality function deployment, or QFD. Now, this is quite a complex tool, but in essence, it's a simplified matrix, and it shows the relationship between customer requirements and product or process technical requirements or activities. Again, this is an established quality tool dating from the 1960s in Japan, which has been adopted within Six Sigma. Now, the complexity of the approach should be suited to the complexity, of course, of the product, the process, or the organization. And I've seen these as quite simple matrices where you have the customer requirements listed in the rows there on the left. And then you have your technical requirements in the columns, and you show the relationships between each using symbols. And like I say, some of these can be very complex. It depends on the system or process you're working on. I prefer a simplified approach myself. Okay, so I'm going to put up a summary at this point. And like I said, I welcome any questions. I've aimed this as a introduction and overview to Six Sigma. So please pass some questions forward, which we'll attempt to answer within this webinar, or even use them as subject areas for future webinars, possibly. But just to summarize what we've been through there, so Six Sigma, what is it? It's a methodology, and it is based on established quality management principles. It enforces a methodology and an analytical approach to process improvement. It includes statistical tools, but it is not just statistical tools. I would emphasize that. I think a lot of people have put off Six Sigma immediately due to the reference to statistics, often believing that perhaps they don't have the data, they don't have the volume to apply meaningfully any statistical tools. And that is quite possibly correct, but Six Sigma, the methodology, DMAIC, the tools and the techniques contains much more than just the statistical tools. So I would try and see beyond the title Six Sigma. Now, it focuses on variance reduction and it has a cost-benefit focus. It ties process improvement matrices and measures to cost. It is cost-focused. Now, whilst the DMAIC method should be followed, the tools and approaches within each stage should be tailored to suit the organization. There is no real set tool set. The methodology is set: define, measure, analyze, improve, control, which is, as we've shown, similar to plan, do, check, act. But it's not a rigid set of tools. So if you're looking for a menu or prescriptive way of doing things, Six Sigma isn't that. It is a body of knowledge within a framework which requires knowledge of those tools and an application of those tools as needed, as necessary. Six Sigma, yes, it requires, of course, organizational commitment, structure, responsibilities, and training. It does require those things, often quality management, quality improvement. It can be held within the quality department, quality engineers, quality representatives, popping out every now and again, trying to improve things through audit or inspection, what have you. Six Sigma does go far beyond that. It really does create an organization-wide structure, responsibilities, and that framework is in place so that everybody is committed to the improvement projects and the improvement initiatives. Everyone is engaged, and everyone is given the time and the resource to do improvement activity. And the last point there, Six Sigma, reducing costs and improve customer satisfaction, which was the title of the webinar. It achieves this by improving the quality of process outputs, focused on the needs and expectations of the customer. As we highlighted, the DMAIC approach at the very front end engages the voice of the customer, and it's the voice of the customer that drives the improvement process, improvement activities, and ultimately the measure of achievement of any process improvement. Okay, that is all I was going to present. Like I say, I'm happy to take some questions and try and answer some things live as we speak. But thank you all for listening. I hope it was useful and informative. But like I say, please be aware that it's just an overview. Okay, the body of knowledge required for Six Sigma is extensive, and you should seek out further training and information before embarking on any Six Sigma program. I should mention there as well, PECB does run training courses, and if I could also just mention myself, I support ISO in the Sun in Lanzarote with Six Sigma training, and there'll be some later in the year which I will be hosting if anybody is interested. Okay, so I'll be happy at this point to take any questions or comments. My contact details are also provided there. If anybody would like to email me after the presentation or at any time, any questions on Six Sigma or even general discussion, I would be happy to take any questions.
Okay, thank you, Martin, for this great presentation. We have received some questions, so before we proceed with them, I would like to inform that, as you mentioned, that PECB provides training and certification services for Six Sigma Yellow Belt and Green Belt. This methodology will guide you through cost reduction in your company as well as increased customer satisfaction. So now we'll go ahead and take some time to answer some of the questions from the attendees. The first question is, how can Six Sigma be applied to disruptions? These could be natural disasters, technology, or human disruptions. Is the question of one of our attendees.
That is a very good question. So, sorry, if I did hear correctly, how can Six Sigma be applied to disruptions?
Yes.
The kind of the kind of unforeseeable natural disasters, that is a very good question. It's obviously geared, as I showed in the slides there, to improving established processes. There is another side to Six Sigma, which I didn't get into in this webinar, and it's basically design for Six Sigma. So designing products and processes. It's similar to the DMAIC cycle, it just has some other slightly different phases. But I think in terms of avoiding a natural disaster, something really left field, I would be struggling to answer that one, to be honest. Obviously, there is a voice of the customer at the front end of the DMAIC cycle that could be broadened into the voice of all external interested parties, as well as the business environment, the political environment, a lot of the kind of PESTL, if you know that acronym, areas that an organization needs to monitor, which can help to avoid disasters. But in and of itself, I would say Six Sigma, what makes Six Sigma is the drive towards reducing process variation. So I would answer that question by saying, strictly speaking, in the strictest sense, Six Sigma is not a tool for avoiding disaster and large-scale disruption. I would recommend other risk analysis tools to do that.
Thank you, Martin, for this answer. We will proceed with the next questions. One attendee wrote, what does the future hold for Six Sigma?
That's a very good question as well. Six Sigma, I mean, it started in the 90s, really, or certainly in the UK, in my experience. Grew in popularity. It now does have its detractors, like most quality management or even management initiatives. They come from nowhere, really. They grow in popularity. They become widely adopted, and then I think primarily because certain people don't reach the expectations that a lot of these programs promote. These things become criticized and they lose their popularity. I think what I would say, and as I showed in the webinar there, you know, Six Sigma itself is based on knowledge, theory, teachings, if you like, that go back a very long time. You know, Deming and Schuhart in the 1920s were dealing with process variation. Some critical people say that Six Sigma is nothing more than just rebadging of existing quality tools. I didn't quite go that far, but I did highlight the lineage to common quality tools, common practices, common improvement approaches. So Six Sigma itself, the future of Six Sigma, I don't know. I mean, yes, there are a lot of critics out there, as there are of 9001 and any other quality program. I think applied correctly, though, you know, a methodology that utilizes data, utilizes information in the hands of competent people will achieve the result. It might get rebadged in time, relaunched as some other name, I don't know. But I think if you understand the tools, if you're competent in the tools and the method and the approach, whatever it turns into in future, it will remain. There will always be a desire for process improvement, quality improvement, and I believe that will always rely on proven tools and techniques, like I say, that have been around for 100 years.
Thank you, Martin. The next question is, are there different processes for handling measurable data and variable data?
Sorry, measurable and variable?
Yes, correct.
I don't quite understand the difference between measurable and variable, but there are differences between attribute data and measurable data, yes. Attribute studies, you can apply statistics to them. I always find it a little bit, it's not really as effective as it is to variable data. So yes, there are tools and techniques and you can apply it to attribute data. I don't know if that was the intent of the question. So yes, pass, fail, or colors, red, blue, green, the methodology can be applied. And again, I would outline again, as I try to make the point in the slideshow there, Six Sigma takes its name from statistics and process variation, but that is not just what it is. And I think if you look across that DMAIC roadmap that we showed you there and all the tools and techniques underneath, there are many of those that can be applied to non-measurable data, more kind of attribute data quite easily.
Thank you, Martin. We'll proceed with the next question. One attendee wrote, how does data from interviews and surveys get used in a Six Sigma improvement project?
Yeah, that's a good question. Survey data, it can often be constructed where you ask the respondent to kind of grade you. For example, customer satisfaction scores out of 10, where 10 is very satisfied and 1 is not satisfied at all. That can provide data. It's a little like the previous question in that the application of statistical techniques such as reduction and variation, the sigma, the process spread, for such data is perhaps not the tool to use in such cases. I would suggest, quantifying in some way via scoring the feedback that you get through interviews or surveys, and then possibly Paretoing those. Hopefully you're all familiar with the Pareto, where you basically rank the responses in the most received down to the least, and then you can focus on the top 20% issues that give you 80% of your problems, rather than trying to focus on everything or randomly selecting what might be the best choice. So yes, it is possible. It requires you to, like I say, score or rank the interview in some way to quantify what is essentially qualitative data. But yes, you can then apply analysis to those.
Okay. The next question is, in general, the Six Sigma audiences is operational workers without background in statistics. How to explain this to employees? An attendee asked.
Yes, yeah, that's a very good point as well. I think as well, if I go back to the structure slide that we showed, within Six Sigma, you do set up this structure of black belts, green belts, yellow belts. Now, the level of learning, particularly within statistical tools, goes up as you go up the belts or up the organization. So black belts, they tend to be senior managers or, well, middle managers, senior engineers, and there is a lot of teaching. I mean, generally a black belt course is a 2-week study plus project implementation, and you'll learn all about capability studies, Taguchi methods, loss functions, quality function deployment, everything else we've shown you, and a lot more besides in statistical tools. Now, obviously, you wouldn't expect everybody to be at the same level, so it's generally the master black belt or black belt that has a very high level of statistical training. The green belt has an awareness of the tools and can apply the tools. Yellow belts, it's more the identification of process improvement, really the low-hanging fruit. I wouldn't expect yellow people at the very bottom end of the organization to necessarily understand the mathematics and the statistics behind it. I think they should be given an appreciation of what Six Sigma is trying to achieve. I think the analogy as well there with people's heights and the variance, in my experience, people understand that, and they appreciate that, and therefore can appreciate what you're trying to do when you talk of process variation reduction. But yeah, I wouldn't blind them with statistics, no.
Thank you, Martin. We will now proceed to the next question. What top tips do you have on catering Six Sigma phases to a more agile manner of delivering improvements?
Yeah, that's a good question. Agility and structure, they're kind of opposite ends, aren't they? They're competing forces. I understand the question. A lot of organizations do work in very volatile environment, shall we say. So they need to be agile, they need to adapt quickly. I think it really is down to the organization. You know, if they do operate in that kind of environment, then they need to have a similarly agile process. I think it should still go through the phases, but it is important not to get bogged down in such situations in too much bureaucracy. It can almost become a form-filling exercise if you're not careful, and you don't want to create another quality management system with your Six Sigma improvement process. So agility can be implemented or can be adopted. I would be careful of it though, because like I say, it is the antithesis really of structure, and Six Sigma is about structure. Agility is often a loosening of structure or even an absence of structure. So it can be difficult. I would caution it, but as long as the DMAIC phases are followed intelligently and intentionally, it could be applied to a more agile environment, yes.
On behalf of SoftExpert, thank you for the presence of everyone who participated in this event. If you have any questions, please contact the presenter via email. To see other webinars, ebooks, and white papers on this subject, please visit our website at www.softexpert.com. Find out more about SoftExpert solutions for enterprise business processes improvement, automation, corporate governance, excellence, and compliance management. Thanks for listening. See you next time.